Yes, Assalamualaikum. Good morning. Okay, so this topic for rearrangement. So first we look at the type of rearrangements. So we can divide to two, intramolecular, okay, and then intermolecular. Okay, intramolecular means it's the same molecule, right? Only involved for one molecule. Okay, but for intermolecular, it involves more than one. Two and more compounds. So that's what we call intermolecular. So for the intramolecular process, the group that migrate is not completely detached from the system in which rearrangement is taking place, because it's a one compound, so it's not completely detached for the rearrangement, the migration of groups. Okay, but for intermolecular process, okay, the migrating group is first detached and later retached at another site or another compounds, right? Because they are involved different compounds. Okay, that's why the migrating group, okay, is firstly detached, okay, and then retached to the new molecule, to the other molecules. Okay, so in this course, we are going to discuss about 5 types of rearrangement. First one, rearrangement involving the electron deficient carbon, mean lack of electron, carbon that lack of electron, which is a Wagner-Mervin rearrangement and pinnacle rearrangement. And second, rearrangement two electron deficient nitrogens. Okay, we like the Beckmann rearrangement. Okay, and then third is a rearrangement to electron deficient oxidants. I'm going to look at the Bayer-Villager reactions. Okay, and then rearrangement to electron-rich carbon. So there are two rearrangements that we consider for these sections: Pavotsky and Witt rearrangements, and finally aromatic rearrangements. So we look at Fries and Claisen rearrangements. Okay, so first we look at the rearrangement Wagner-Mervin rearrangement. Actually, it's involved for carbocation rearrangement of carbocation. The one that we already learned in the previous topic. Okay, but apply for this rearrangement for the Wagner-Mervins. Okay, so the concept we already learned, so it should be easy. Okay, it should be simple. Okay, so the first step should be the remove of water, okay, to form carbocation, okay, to form carbocation, and then rearrangement, okay, rearrangement. Okay, for example, like in this case, this is a primary carbocation rearrange, involve the migration of methyl group, okay, of the methyl group to form tertiary carbocation, okay, and then you can form either it's a substitution or elimination product, right? If a substitution, you form alkyl halide. If elimination, we form alkenes. You form alkene, and we form, in this case, we form the major product for the alkene. Okay, although for this carbocation, actually you can form another one, alkene, double bond at these positions, which is a minor product for the elimination, or we call the E1, and the E1. Okay, for this one is a SN1. Okay, this is another example. Another example from this cyclic alcohol. Okay, and then the remove of water, deprotonation and remove of water to form carbocation. The original carbocation is a secondary, so there are possibility to form more stable carbocation, which is a tertiary, which is tertiary. So how to do it? How to do it? Okay, so at this stage we need to think about there are three possibilities, and there's a hydride shift, metal shift, or ring expansion. Yeah, so in this case, we form, actually it's not ring, actually it will break at this bond, okay, this bond, okay, and then attach to this carbon that which lack of electron, okay, to form new positive at tertiary position. You form tertiary carbocation. So you form actually this bicyclic system from one. This a bridge, okay. So we form this system. This is tertiary, more stable. Okay, and then you can form elimination product for this example. It is another example. It also can form carbocation from alkyl halides, yeah, for sure. Not just from alcohol, but also can from alkyl halide. Okay, and then this is secondary. Okay, you can form tertiary. Okay, using metal shift. Okay, use metal shift, migrate these positions. Okay, or if I okay, so migrate to these positions. Okay, so this one we call 1-2 meter shift because it involves position 1 and 2. 1-2 meter shift, okay, to form this tertiary. This is tertiary carbocation. This is secondary. So tertiary is more stable than secondary. Okay, that's why the arrangement, the migration occurs. Okay, so and then it will form product. Okay, so product can form as a substitution. This is a substitution or elimination product. Okay. This is another example. It's another example. It form secondary. Okay, and then, but in this case, okay, but in this case, it not form tertiary. Okay, why? Okay, because this one not just for the this one not just we call this a secondary carbocation. It's a special because next to the benzene ring. This one we call benzylic. Okay, this is a benzylic carbocation, which is among the most stable carbocation because these are positive. It can be stabilized by the localization of a benzene ring, and that's why for this case, we will not rearrange to form tertiary because this benzylic carbocation is more stable than this normal tertiary carbocations. Okay, and then we look at another example using different functional group. Okay, so the first step in this case we use amines. The first step formation of carbocation, and this equation show the mechanism. Okay, how we can form the carbocation. Yeah, how we form carbocation, and it will form the side product as a nitrogen gas. Okay. So once it form carbocation, okay, so it can form product. You can form product. This is elimination and substitution product. Or actually, because this is primary, so it can rearrange. You can rearrange. In this case, we form ring expansion. Okay, so mean break this bond. Okay, and then attach to this carbon. Okay, so these are positive. Actually, refer to this carbon. Okay, this carbon. This is positive, right? Because they already lack of electron. Because this bond usually just share electrons. Okay, between this carbon and this carbon, both share one electron. But for the migration, both be used to bond with this carbon, with this carbocation. Okay, that's why we form a positive at this site, this new site. Okay, and then we form a new product, which is in this particular case, substitutions. It's a major product for this experiment, almost 60%, compared with